Hello everyone. First of all, I'd like to thank the organizers of this conference for this opportunity to present our research. My name is Beste, I'm a PhD student from Cyprus and I'm studying in Ankara University. Today, I'm gonna present our study about the anti-cancer activities of a plant species which is endemic to Cyprus. The topic of our study is the enrichment of anti-cancer activities of Phlomis brevibracteata turril on HCC cells with sub-extraction. Before we start, I'd like to introduce us. We all work at the Faculty of Pharmacy of Eastern Mediterranean University. The university is located on the island of Cyprus in the Mediterranean Sea. Cyprus, with its particular location in the eastern part of the Mediterranean, presents one of the richest flora in the area. Among the subjects we study are medicinal plants and anti-cancer activity. As stated in the title, we worked with Phlomis brevibracteata species in this study. The genus Phlomis belongs to the Lamiaceae family and encompasses 100 species native to Mediterranean region of Turkey, North Africa, Europe, and Asia. Phlomis species are used to treat various conditions such as diabetes, gastric ulcer, hemorrhoids, inflammation, and wounds. Phlomis brevibracteata is an endemic plant which grows in Kyrenia, Carpathia, Nicosia, and Limassol regions of Cyprus. We collected this plant from the marked region, which is called Kantra Castle Peak. Plant was defined by Professor Dr. Neriman Özatay. Cancer is a condition where cells in a specific part of the body grow and reproduce uncontrollably. Hepatocellular carcinoma or liver cancer occurs when a tumor grows on the liver. The incidence of HCC has been rising worldwide over the last 20 years and is expected to increase until 2030 in some countries. It is considered as the second leading cause of cancer-related death worldwide with over 500,000 people affected. Especially in recent years, studies on anti-cancer activity with plants have been increasing rapidly. A medicinal plant is defined as any plant species that contains secondary metabolites that can be used for the therapeutic purposes or can be used as precursors for the synthesis of new drugs. Studies on these plants are of great importance in drug discovery in the treatment of cancer in the coming years. In our previous studies, we investigated the anti-cancer activity of crude extract of Phlomis brevibracteata. We extracted dried aerial parts of the plant with 70% methanol. We investigated the anti-cancer activities of extract on some liver cell lines. We used SkyHep1, HU7, and PLC-PRF5 cell lines. We used MTT, wound healing, and DCFHDA assays to determine cytotoxic, 2D motility, and intracellular ROS scavenging effects. Methanolic extract of Phlomis brevibracteata showed cytotoxic, antioxidant, and motility inhibitory activities on SkyHep1 cell line. This has given us hope that we can obtain potential anti-cancer agents from this plant. For this purpose, we decided to resort to the bioactivity-guided fractionation method. On this slide, you can see a draft of our study plan. We fractionated 70% methanolic extract with N-hexane, ethyl acetate, and M-butanol by liquid-liquid extraction. We did this to try to enrich the active ingredients responsible from the biological effect by solvent fractionation, and also we tried to find out potential anti-cancer activity of N-hexane, ethyl acetate, and M-butanol sub-extracts of the methanol crude extract of PBT. Activities of the sub-extracts we evaluated using MTT, wound healing, and DCFHDA assays to assess cytotoxic, antimetastatic properties, and intracellular ROS scavenging activity of the plant, respectively. We used MTT assay to determine cytotoxic activities of sub-extracts. The MTT assay is a colorimetric assay for assessing cell metabolic activity. Our results showed that all of the extracts were cytotoxic for the SkyHep1 cell line, as a significant decrease in percentage cell viability was noticed. As shown in figures, they decreased cell viability in a concentration-dependent manner. As can be seen in the graphics, the crude methanol extract decreased cell viability at higher doses than the subfractions. In addition, N-hexane and ethyl acetate subfractions were found to be more effective than N-butanol subfraction according to IC50 values. In our further studies, we can think about to isolate active compounds from N-hexane and ethyl acetate subextracts. We used wound healing method to determine 2D cell motility. It is a method used to study cell migration and cell-cell interaction. As you can see from the representative photos of wound healing at concentrations above 5 microgram per milliliter, hexane faced a drastic decrease in the SCI-HEP1 cell line. Adenocarcinoma cell line migration was observed. At concentrations above 25 microgram per milliliter ethyl acetate, a drastic decrease in the cell migration was observed. However, we couldn't observe any drastic decrease in the cell migration for N-butanol fraction. According to the results, we can say that the N-hexane and ethyl acetate phases are more effective than N-butanol phase. This makes them good candidate as an antimetastatic reagent. We used dichloro-dihydrofluoroocane diacetate in abbreviation DCFHDA assay to determine Ross scavenging capacity. DCFHDA is a nonpolar and non-fluorescent molecule that has the ability to diffuse through cell membranes into the cytoplasm, where it is enzymatically cleaved by intracellular esterases to the polar non-fluorescent DCFH. This molecule then becomes trapped inside the cell and is oxidized by Ross, producing the highly fluorescent 2,7-dichlorofluorescine. As we can see from the figures, all extracts was significantly effective on basal oxidative stress of SCI-HEP1 cell line. Ethyl acetate and N-butanol subfractions were more effective than N-hexane subfractions. This shows us that antioxidant substances are more in ethyl acetate and N-butanol fractions. Also, N-hexane subextract was not significantly effective on induced oxidative stress. N-butanol fraction was the most effective one on induced oxidative stress. N-butanol extracts showed nearly same dose-dependent manner with methanol crude extract. In this slide, we can see IC50 values of crude methanol extract and N-hexane, ethyl acetate and N-butanol subextracts for MTT and DCFHDA assays. In conclusion, we can say that all extracts of Phlomis brevibracteata have strong cytotoxicity activity on SCI-HEP1 cells. Butanol extract was the least effective and hexane extract was most effective fractions in terms on both antiproliferative and antimotility effects on SCI-HEP1 cells. Ross scavenging capacity of ethyl acetate and butanol extracts were higher than hexane extract. We will continue our research with the isolation of active compounds from active fractions and investigation of anti-cancer activities of isolated compounds. Thank you for listening to me.